I'm trying to analyze this truss, but I just don't get it. It's too confusing. For the given truss, determine the member forces in DE, KE, and KJ.
I can help you with this.
Thank you.
Bam!
Whoa, where did that come from?
First, let's draw a free body diagram. Make sure to label and dimension it. Then add the external forces and support reactions. Why don't you come over around here and we'll take a closer look.
All right. So what are we doing with moments? What are they?
That is the first lesson in a very good example of moments. Let's take a closer look at what just happened. So, here's your table, the table surface there, and you have the two supports. Those are the two legs. Here is the weight of the table, holding it down, and then here was your weight on the edge there. Now, in order to make the table not tip, we would need to provide a counterweight on the opposite side of this support.
Okay.
Now let's apply it to our free body diagram over here. To begin, we need to solve for the support at H. To do that, we'll use the moments about point A. To visualize this, essentially what we're doing is we're finding the support needed at this point here so that it does not rotate. To find the sum of the moments, we multiply the moment arm of each force by the magnitude of that force. And then we solve for HY, which is 62 kilonewtons. So now what members do we need to solve for?
We need to find this one here, and this one here.
So what will we do next to solve for them?
Would we find the other support reactions?
No. We're going to use method of sections.
Oh.
Let's look at this section. Again, we draw our free body diagram, making sure to label it and add the forces and support reactions. Now, in addition to the external forces, we have the three force members we want to find included in our section free body diagram. In order to begin solving for these member forces, we will sum the moments about point K. Because FJK and FVK pass through point K, we can ignore them and solve for FDE. So FDE equals negative 82.5 kilonewtons. Since now FJK is the only Y component that we don't know, we can solve for FJK by summing the forces in the Y direction. So FJK equals 95 kilonewtons. Since the only x component that we don't know is FEK, we can solve for FEK by summing the forces in the x direction. So FEK equals negative 7.5 kilonewtons. So FJK equals 95 kilonewtons. FEK equals negative 7.5 kilonewtons, and FDE equals negative 82.5 kilonewtons. Since FEK and FDE are both negative, that means they are compressive forces, while FJK is positive, which means that it's in tension. Does it make sense now?
Yeah, it does. Thank you.
Oh. All right, there you go. I'll see you around.
Yes. Done.
Here's your next assignment.
I know how to do this. Yes.